Great. So density is the most common of these derived units that we work with. You'll know it's a derived unit because it has weird labels. So if I look at the value for density, the label, mass is measured in what unit? Grams, and volume is measured in milliliters. This is my clue, derived unit. The labels don't cancel out. Centimeters cubed, that's a derived unit. I had to use an equation to calculate volume. So I said volume was length times width times height, which made it cubic centimeters, derived unit. The unit for gravity, meters per second, that's a derived unit. It came from an equation, and it was a relationship of things I could observe. I could observe change in distance and change in time, and so I used those to find a relationship. So this whole category of units are called derived units, and we use them to describe properties of matter beyond the basic, how much stuff do I have? So I have two substances today of equal volume. Okay. So exhibit. So density is the broken heart equation. It's mass divided by volume. We call it the broken heart equation because it looks like a heart broken in half, M over V. Sure. And we remember that mass is measured in grams and volume is measured in milliliters, which means that the label for all density equations will be grams per milliliter, or it will be, we remember that 1 milliliter is 1 cubic centimeter. So if I have grams per milliliter, it's the same as grams per cubic centimeter. Great. So for example, for water, the density of water is a standard that you just should learn for science. Anybody know what the density of water is? One what? Density for water, 1 gram per milliliter, or 1 gram per cubic centimeter. So here's my Red Bull. If my Red Bull was full, it had a volume of 250 milliliters. If I made the statement that the majority of Red Bull is water, then I would say, if I had a mass, what would the mass be if the volume is 250 milliliters? And I said the statement that the density was 1 gram per milliliter. Then Cameron, what would the mass be? 250 grams. So in my water bottle, I have, it measures in metric. So I have 350 milliliters of water. So if I said, what's the mass of just the water? Carlos, what's the mass of the water if I have 350 milliliters? And the density is 1 gram per 1 milliliter. 350 milliliters. I can solve it. D equals M over V. If this is 1 gram per milliliter, and my volume is 350 grams. Yeah. I multiply both sides by 350. 350 milliliters times 1 gram per milliliter. Milliliters cancels. The answer is 350 grams. It's a useful property of a substance to know. It's so useful, in fact, that we have it listed for every element on the periodic table. So if I look at my periodic table, my complete periodic table, not the ones that you guys have, but if I look at my periodic table in the bottom right-hand corner, like I look at my key tells me density is the value in the bottom right-hand corner. So here's my key. It says it's this one, this itty-bitty little one. So if I look for iron, iron has a density of 7.87 grams per milliliter of iron. If I look at gold, AU, give me back my gold. AU, where is it? Thank you, 79, here it is. Gold is 19.3. So water was 1. So if I have 1 milliliter of water, gold will be 19 times more dense. So it'll have 19 times more mass in 1 milliliter. So if I had 1 gram of it, right, so 1 milliliter, I have 1 gram. And if I have 1 milliliter of gold, I have 19.3 grams. So here I have the equal volume. This is ammonium hydroxide. And here is equal volume of liquid mercury. Right, so we're going to make the statement that this is dissolved in water, and for the most part, it's really close to a density of about 1. And here's liquid mercury, which we said mercury had a density of 13.53. So go ahead and pass it around. This is density. That's what density means. Equal volume, but the amount of matter inside of it is drastically different.